Okay, so in this example, I'll do a one sample t-test. We'll pretend that these data here are a sample of 7 people, and this is the number of text messages they sent during a given class. Let's pretend that the mean number of text messages sent during a class is 1.5, and we are comparing the population from which this sample was taken to the mean of 1.5. We will use the one sample t-test formula, where t observed or t obtained is computed by taking sample mean minus the population mean over the standard error of the mean. And first step in doing that is we'll need to compute the mean. So to compute the mean, we'll first take sum of x. Sum of x here is 26, so just sum of all the scores together is 26. And the mean is going to be 26 divided by 7. Which gives us 4.3944. Okay, the next step is we need to compute the standard error, which we'll do by way of computing the sum of squares, then the variance, then the standard deviation, and then finally the standard error. So first step is to compute the sum of squares, which we compute by taking the sum of the squared x's minus sum of x squared over n. Sum of the squared x's, we'll first need to square up all the scores. So 25, 16, 36, 4, and so on. So we square all of the scores, and we get sum of the squared x's, which here is 116. So we have the left-hand side of the sum of squares formula, which is 116. Subtract sum of x squared, that's 26 squared, divided by n, which is 7. Sum of squares is 19.4286. To get the variance, we simply divide the sum of squares by n minus 1, so we have 19.4286 divided by n minus 1, which here is 6, which gives us a value for the variance of 3.2381. Then we can get the standard deviation. Standard deviation is simply the square root of the variance. Square root of the variance. The standard deviation is 1.7995. And then finally we can get the standard error by taking standard deviation 1.7995 and dividing it by the square root of the sample size, which here is 7. So if we take the standard deviation and divide it by the square root of 7, we get the standard error of the mean, which is 0.6801. So this allows us to compute our t observed. So our t observed is going to be our mean, which was sample mean, which is 4.3944. Subtract our population mean of 1.5 and divide it by our standard error of 0.6801. Gives us a t observed value of 4.26. So if we are, let's say we're doing a one-tailed test with alpha 0.05, our degrees of freedom, since there's 7 people in our sample, our degrees of freedom would be 6 and minus 1. So we'll have 6 degrees of freedom, alpha 0.05. Our one-tailed t-critical value is 1.94. And assuming we were doing a right-tailed test, meaning we expected this sample, the population from which the sample came from, to be significantly greater than 1.5, we would need to exceed 1.94 on the right-hand side of the distribution, which we clearly have done because our t observed is 4.26. So we would reject the null hypothesis. Finally, we could also compute the effect size, which will be Cohen's d, by taking the numerator from before, which was 4.3944, subtracting 1.5. There's 2.8944. Divided by the standard deviation for Cohen's d. We divide by the standard deviation, which is 1.7995. And we get a value of 1.61, a rather large value for Cohen's d for effect size for this one sample t-test.